So the pH scale is a way that we measure whether a substance is an acid or a base, or how acidic or basic it is. So it tells me about the strength of an acid or base. And when we talk about pH, pH tells us, like I said, the acidity or the basicity of a substance. And we have this scale which is called the pH scale. It goes from 0 to 14. And anything below 7, those are considered acids. Anything above 7, those are considered bases. So on either end of the spectrum, like this would be the very strongest acid. Over here, this would be the strongest base. And as we get closer to the middle, that's neutral. And so if we were here at 8, 9, and 10, we would say that's probably a weak base. Whereas our 12, 13, 14, those would be strong bases. 4, 5, 6, those would probably be weak acids. And 0 to 2.5 or 3, those would be considered strong acids. So you can see they filled in some items here. Coca-Cola drinks, or Pepsi Cola, whatever your pop drinks are, because they contain carbon dioxide, that's carbonic acid. Citrus fruits, tomatoes, those things are acids. Where we get over here, we have bases like baking soda, milk of magnesia, and ammonia. So pH means the power of the hydrogen. And to find pH, we always take the negative log of our hydrogen ion concentration. And on your calculators, you're going to have a log button, as long as you have a scientific calculator. And so you're going to have to enter the number, and then you're going to push log, and then you'll probably end up with a negative number, so you just drop the negative. If you have an expensive graphing calculator or something like that, then you actually enter negative log and then the number. But for most of your calculators, I'm guessing you'll probably want to enter the number first, then push log, and you'll look for that LOG button on your calculator. It'll give you a negative value, and then just make it positive. So here's some examples. If we have an H plus concentration of 2.5 times 10 to the negative 5th molar, so you'd want to enter that number in your calculator, then push log. You'll come up with a negative number, drop the negative, and you should get 4.6. If this is your H plus concentration, you'll once again put that number in, then push log, and you'll end up with a negative number, so drop the negative. You should get 10.46. If this is your H plus concentration, you'll enter that number into your calculator, push log, drop the negative, you should get 5.77. And like I said, for most of your calculators, you'll want to actually enter the number first, then log. Now, as I mentioned before, if you have a graphing calculator, you can push negative log of that number. And you'll probably want to make sure you have that number in parentheses, so it gives you the right value. So we can see by these that this would be probably a weak acid because it's a 4.6. 10.46 would be on probably the weak base side. Well, almost a strong base, I guess. And 5.77, this would also be considered a weak acid. Okay, so here's some different substances with their pH values. These are the ones that they had rated on that chart. So here you can see the actual numerical values. So if we want to go backwards and we want to find the H plus concentration from the pH, we can do that as well. So to go backwards, we're going to have to do the opposite of the log function, which is taking 10 to that negative value. So if we have a pH, we do 10 to the negative pH. So if we have a pH of 8.7, you do 10 to the negative 8.7. And you want to make sure when you're putting that in on your calculator, you may have a 10 to the X button, or you may just push 10 and then use your caret key, and then make sure you enter your plus minus key, not your actual minus sign for subtracting, but like your plus minus key, 8.7, and it should get you a value that's 2 times 10 to the minus 9th. So we're going to work through a few more examples. If we have a pH of 5.46, so I'm going to do 10 to the caret negative 5.46, and I got an answer of 3.47 times 10 to the negative 6, and that would be molarity. So I'd have a capital M as a label. So another one, if I have a pH of 7.8, once again I do 10 to the caret negative 7.8, and my calculator is 1.58 times 10 to the negative 8th, and once again that would be molar. And if I have a pH of 11.2, 10 to the caret negative 11.2, and I get 6.31 times 10 to the negative 12. And one thing I kind of want you to look at is if you look at the pH here, this number is around 6. It's 5.46. If we look at the exponent that I got for my molarity, I get a 6. Actually, it's a negative 6, but if you just look at the number, it's a 6. Here, I have a number that's 7.8. My exponent is 8, so those are pretty close. Here, I have 11.2, and my exponent is 12. So those should be fairly close together, the exponent, if it's a positive here, and the pH. That's going to tell you that you did it properly. So in this case, if we have an H plus of 1 times 10 to the minus 8th, then on my calculator I would do negative log, or on a regular calculator you probably have to enter that number and then push log, drop the negative, and you get a value of 8. So if your value is 8, we would say that that is slightly basic.